started, hopefully you're selected pizza and here. My name is Abhijit. I'm a corporate solution engineer, and I have one of my colleagues, Andrew. I'm not sure of his last name, but Andrew is another colleague of mine. He's more Java buff than me, so he's going to present how to build an application. All right. So the brief agenda for today is why Yarn, right? So there's a lot more to Hadoop 2.0 and what Yarn offers, and then we'll talk about the architecture and concepts, and then Andrew will go into building applications. And we have a sample applications we have built, so you can go on our GitHub, copy it, and just reuse it for your own use. For the next step, we'll talk about a little bit how other companies are building applications on Yarn, what we have available today on Yarn, and how you can get the code either from GitHub or from our website or from our dashboard. All right? So we all know this diagram right on this slide. So when we started Hadoop, or I should say when Hadoop was started at Yahoo, because Hortonworks essentially is the spin-off of Yahoo. So our team started building Hadoop in around 2004 timeframe. And then one of the primary use case was to build a larger storage space and compute platform, right? One of their major applications was web. So they used to crawl web and capture all the page information and build some sort of graph for their downstream applications. So the majority of the use case was, bring the data, compute it once a day or twice a day. So the majority of they focused on batch processing, right? So we all know for the past few years, as Hadoop becomes more mainstream in the data processing applications throughout the enterprise, a lot of customers started using way more than what they're designed for, right? And anytime you ask a developer that you can only stretch the algorithm so far in the implementation, then you need a new algorithm, right? So that was the thought process behind Hadoop 2.0, or the next generation of Hadoop platform. So we see today lots of online applications, like streaming applications, as well as getting data faster, analyzed faster is more important for customers, right? And we all realize that. Every customer we walk to, they have large amount of clusters where they want to process the data faster, right? If you want to do a fraud detection, you want to know right away rather than waiting 3-5 minutes when a Nigerian prince sends you an email, right? I'm sure everybody has got that email. But the idea is to process that fast enough. So when it started, we knew this is our old MapReduce 1.0 framework that we all love and we all use today. From a conceptual point of view, we already had a centralized job tracker, which we use as a centralized scheduling resource management engine, as well as an application engine. Right? So it does both application management and resource management. So you have a job tracker where you submit a job, and you have task tracker where they execute all the jobs. Right? Very simple. You have per node agent, or the slaves, what we call task tracker. They execute the task, they report back into job tracker, and voila, you have your task or job clear. But while it lasted great for us for the past few years, it had its own limitations, right? And we saw that for the past few years. As a company, we manage Yahoo's infrastructures for Hadoop, and we have seen the limitations going on. So one of the limitations we saw is we cannot scale the clusters beyond 4,000 nodes. And not here, everybody has 4,000 nodes, but there's a scalability issue. The other issue we saw is as the hardware keeps growing and growing, you can get all the analysis done in less amount of hardware that you originally had, right? So whatever you had done with 4,000 nodes, with the size of hardware today, you can do it potentially 2,000 nodes. Because the hardware is growing every year, potentially every 6 months. The other issue we saw was a concurrent task. So maximum concurrent task we were able to run were 40,000, right, in those clusters. And it depends on everybody's application, but we wanted to go beyond that maximum concurrency status. The reason behind that is if you look at MapReduce 1.0, the resources are basically split into your map slots and reduce slots. And what we have seen is people wrote applications that they just use map slot and they never use reduce slot, right? So even though you have reduce slots configured, you're essentially wasting memory and resources when you configure that, right? It's MapReduce 1.0, it's stealing memory from your resources. So the idea was to utilize the cluster better with the same amount of resources. And we have some numbers for our testing, what we have done, and I'll share that with you in the next few slides. The other thing was the core synchronization in Job Tracker, because Job Tracker does both resource management as well as application management. And over the period of time, we realized application management is hard, right? Not basically from a design perspective, but what Job Tracker has to do on its own, because it's tracking your job, it's looking at a lot of counters, it's looking at the task, it's doing preemption, all it's happening on a single daemon. So we couldn't scale because if the Job Tracker failed, there's another issue. And if application has some issues, the Job Tracker single daemon needs to be involved. Availability, right? So failure to queues cause a lot of problems, and not in a smaller environment, but you're talking about 40,000 applications going hard at this cluster. There are certain issues that has a snowball effect, right? So we wanted to make sure that an application management and resource management is separate, and we can control that granularly, right? So that's one of the design principles that they based upon. Low resource utilization. We talked about as MapReduce deals more resources, because some of the unused resources you cannot effectively utilize. So how about taking a granular access to every resource, right? We've seen certain customers, they have R running on existing cluster, and our guys just wrote some scripts that obviously took all the resources, and you had no resource running for a MapReduce slot. So the idea is to control what you can give to the application, as well as have better application management. And obviously lack of support, right? So we wanted to have the more real-time applications in Hadoop, and we have seen this. You have iterative SQL coming up with Cloudera, IBM, as well as Baltimore Stinger project. That's coming up fast and furious. But given the MapReduce paradigm, we're still stuck at the same MapReduce 1 until we go to that next step as TES, for example, as an application, right? So to enable those applications in next generation framework, and that's why we started, or the guy started working on Yarn about 4 years ago. So they submitted Jira around 2008 timeframe, and the real work really done in the last couple of years, right? So we all know this, in Hadoop 1.0, you have single cluster resource management, it's tightly coupled in. HDFS is a great file system, which can scale, which is redundant, and can store your data very cheaply and reliably. And we want to take that further, having this centralized data repository and have all the applications access to that data simply using a singular resource framework, right? And effectively utilize more resources on that. So store data in one place with HDFS, access that data in the same place, and have all the application use the resources available in this cluster, rather than having, I have this edge-based cluster, I have this streaming cluster, I have this MapReduce cluster, and we want to combine those resources together. So today we started around 2 months ago during Hadoop Summit. We started the Yarn certification program. So we're working with a lot of companies so that they can work with us as well as by themselves, obviously, to test and certify their applications on Yarn. Right? So we work with Storm guys, Giraffe guys, as well as Open MPI guys. Right? So Open MPI is now natively run on Yarn as well, right? So MPI is a message passing framework. It's more CPU intensive rather than disk intensive, but now we're able to run that in the same cluster, in the same Hadoop cluster, to be specific, right? So 5 key benefits. If you don't remember anything what I said today, just take this slide with you, right? One is scale, right? We want to scale beyond this limit of 4,000 nodes, not necessarily 4,000 nodes, but effectively utilize the cluster resources. Because when they wrote Hadoop 1.0 and over the period evolved, their idea was 6 processors or 8 processors in a machine, 32 gig RAM, and 4 terabyte disk were great. Now, if you ask that, that's one of your desktops, right? The server is now running 24 cores, 128 gigs and 256 gig RAM, and significant amount of storage space in a singular 2U box, right? And we're not able to effectively take advantage of that resource. So we want to scale not only beyond 4,000 nodes, but we want to scale vertically on that particular physical hardware as well, right? Support new programming models, and we'll talk about that a little bit, and Andrew will talk about that while he goes through the application build. Improve cluster utilization, we talked about this. Now, if you look at MapReduce, now MapReduce becomes a userland library in Yarn, right? So that the other applications can granularly access and request resources in Yarn cluster. Agility is the key. One of the things that we want to focus on agility is because we all know if you're going to go through this motion of upgrading Hadoop 1 cluster to Hadoop 2 cluster, it's a little bit challenging, and we all agree to that because a lot of things has changed, right? You got to upgrade the cluster, take down time, and there are no severely rolling upgrades available, right? So going beyond Hadoop 2.0, when the new upgrades come in, the idea is to have all your applications run in the same framework without a downtime, right? So the idea is to have MapReduce 1, MapReduce 2, as well as all the codes run within the same cluster while you're doing the upgrades. So making rolling upgrades, make agility better because you don't have to take downtime, as well as you don't have to go to your customer and say, hey, we're upgrading this cluster, we're upgrading this resource management, now you need to update your application. So when you update the system, they can eventually move to that particular new code or new system that they're using. 98% of Hadoop is all Java, right? So we want to support other applications where you can use C++, Perl, Python natively in Hadoop easily, right? We still can do that today, but there's still a difficult task of using that. So going beyond Java was one of the critical components of one of the skills. So think about these 5 aspects, and they're important when you design Yarn, right? For those who like history, right? So one of the Jira was created in 2008. It was, I think, 269 to be specific, and led to PMC by Jerome Murphy. So he submitted it because Yahoo originally had that significant issue of utilization. We've been working on Yarn for the past 3-4 years, so now it has been quite stable. And we're running Yarn at Yahoo for the past 6 months or so. So we started deploying that in Yahoo around January timeframe when we had the opportunity to do so. There's no cluster today in Yahoo runs on MapReduce 1. Everything runs on Yarn and HDFS 2. So far we have deployed 35,000 nodes in production. There are significant applications running in Yahoo, and I have some numbers in a few slides that can give you an idea. We're able to increase the utilization. So if you had an opportunity to listen to the keynote that Yahoo delivered at Hadoop Summit, they went from 65,000 concurrent jobs to that cluster to 135,000 jobs on the same cluster on the same hardware. So they're utilizing more and more by deploying this framework. And it has been running for the past 6 months with 2 releases of Yarn. So it's been quite stable, and we're looking at, as a community, we're looking at releasing SGA by September end timeframe. So September end, you'll have Hadoop 2 full GA on HDFS 2 as well as Yarn.
Question. When you talk about these nodes, are they already in production?
Yes.
Yahoo for 6 months. So all these previously MapReduce and all now.
That's correct. Yes. There are 5 clusters of roughly 7,000 nodes on and off, probably running full-blown Yarn applications.
You guys branch out from the beta release, or the beta release which just came out, or from the alpha release version of it?
So, from a Yarn perspective, they're using beta 2 release, so they'll go GA. So there's some significant differences that they'll go from beta to GA, right? So there are some of the Jiras that created during that time frame that will get incorporated. So it's a 6-phase testing cycle. So they go quarterly, test those, incorporate those Jira, then they upgrade the code. So for them, it's not necessarily GA as an enterprise because for them it's important for them, right? So they'll run data code if they have to.
Do you even have nodes on the cluster?
So far from the testing, we've seen close to 10,000 nodes on. That's where the ceiling was with the hardware we had and the heterogeneous scale, but we haven't seen more than that yet.
And Yarn will handle, so if I have four clusters within something within Yarn, I only need Yarn once, I don't have to have four versions of Yarn in each cluster.
That's correct. If you have 10,000 clusters, call me. I'll be referring to this.
I mean, 10,000 nodes on a cluster.
Yes, even that too. All right, so some of the basic concepts on Yarn, there are two things that you need to remember. One is application. So application can be a job submitted to Yarn. So let's think of this way. Yarn is a resource scheduler on a distributed computing environment, right? So if you think of this way, it's like an application or OS running top of this, thousands of nodes in cluster, right? So it can compute. It can give you ability to run resources like CPU and memory, and going forward, they'll keep adding disk resources, network, so you can control what it is. So it's as good as your application asking a Linux server, give me, 2 CPU, 2 vCPUs, and 4 gig memory for my applications to run, whereas Yarn enables you to do so on these hundreds of nodes, or even 2 nodes, what Andrew is going to show you today, right? The second example is a job. So you can submit as a job, which can run as a service or run as a job, right? So when you submit a job, like in MapReduce, it becomes a job for Yarn also, right? But when you look at Yarn, you can run application as a persistent service within Yarn. So let's say you want to run HBase on a Hadoop 2.0, that becomes an application for Yarn, but it's a persistent application, right? You start the application, it runs as long as you want, and for example, MapReduce is a job because when the job is run, it terminates after the job is done. The second concept is a container. So container is a basic resource or a basic unit of allocation. So container essentially is a resource allocation given to you by a resource manager, right? And resource manager basically give you a container today in Yarn only for memory and CPU, right? As the current release goes. In the future releases, by I think next year time frame, we'll have, they'll keep adding to it. They'll have network resources you can consume, as well as disk I/O and storage space, and possibilities are endless. So whatever you think of Unix C group, it uses C groups underneath. So if Unix C groups enables you to do that, it'll be basically exposed to Yarn as well.
Are they just verifying Windows is also supports C groups on Linux
And
control?
job control on Windows, correct. So not only Yarn support Linux, but we actually have Yarn support on Windows as well. So if you're running Windows, which how many of you do, I don't know, but if you run Hadoop cluster on Windows, instead of using C groups, there's a job control in Windows that gives you the same ability to control resources within Windows environment. Right?
How many people, in your experience at Horton, have you seen many people running Hadoop on Windows?
We have so far 3 or 4 customers that are running on Windows.
Just for GA.
Right, so
Very well. The only place they could run before was and now they do this.
right, so that's a good point. Right, so Microsoft recently, from a shipping mechanism perspective, they said we'll deliver to the end time, but then it was kind of restricted. So what we did is we compiled for separate download for Hadoop on Windows. So certain customers, they have just the Windows environment. You don't want to go get Linux or any type of Unix. So we have seen very small customers using that. It went GA around May timeframe. So we haven't seen significant adoption as of Unix. So the question was any performance difference on Hadoop on Windows as well as Hadoop on Linux, right? So given the testing and the scale we have done, the answer is no, because it's only offered on Windows 2012, right? So 2012 comes with a file system, which is the next generation file system that Windows offers, right? So that's basically a significant performance improvement. So we call it RFS, Reliable File Systems. That's one of the things that they worked out with Veritas, and they're shipping now with Windows 2012.
So your answer is Windows is more performant?
It's same or equally performant, yes. Now, feature comparison-wise between Unix and Windows, I leave that to you to do that. But performance-wise on HDFS purely, yes. And there are certain guidelines that you need to follow to get that performance, but obviously you All right, so from an architecture perspective, right, as you know or all love the MapReduce one, it's kind of same but it's different, right? So what's the similarity? The similarity is there's a centralized resource manager which controls the resources within the cluster, right? Which allocates the resources and keep track of resources within the cluster. It's like a job tracker. Every other node, right, within the cluster runs something called as node management. Like previously you had a task tracking. So node manager is the one who has responsibility to allocate to use those containers allocated to that node management, right? So we saw container is the basic unit of allocation, which is CPU and memory given to you by the resource manager. The third thing is the application manager. So now in this case, application manager is where your application runs. It is nothing different or magical about it. It's just a container where you deploy your application, right? And it's a little bit hierarchical, right? So when you, and Andrew will go through the code, but when a client requests an application to be deployed, it essentially submits a request to resource manager. Resource managers come back and say, okay, you want 6 GB of memory, 2 virtual CPUs, great. I will give you a container on node number A, right? That's your application manager. When the application starts, it has responsibility to get containers for whatever it needs, right? So it'll go back to resource manager and say, okay, I need 2 containers on this particular host, or give me where you can find me the resources, right? So all the containers will be the children of the application manager, and the application managers will be the children of the resource manager.
So on a cluster, how many instances of resource manager and the application manager are recommended?
So on a cluster, there'll be only one resource manager,
Okay.
right? And at the moment, there is a JIRA in progress where they will make resource manager highly available. They'll come in Q1, if I'm right, or whatever time frame. But the resource manager redundancy is coming, so that it's like a job tracker redundancy, right?
Okay.
But the beauty is your resource manager is not in path like the job tracker. It's not doing application management. So the resource manager goes down, you restart resource manager on another node or same node, or whenever you fix it, you can still have your application keeps running, right? The bottom line is when the resource manager goes down, you're not going to get any new resources, right? Whereas in job tracker goes down, your jobs are not in progress.
Where does it process the queues, your queue, and all the job information?
We'll get to that.
And what about application manager? How many of them will be there in the cluster?
You can spawn as many as
Let's hit your place code, whatever you submit, application manager represents attention, or whatever you're doing, your service.
So each service or each job is one
You
application?
submit 10,000 jobs, you have 10,000
Okay.
application manager.
Right. So from a resource manager perspective, right, think of it as a job tracker. It has a responsibility of global resource scheduling. Right? It knows how many resources are available within the cluster. It keeps track of, this node has, X number of resources allocated. If the application is managing, if the application manager requesting more resources, it can allocate to that. It basically supports hierarchical queues. So we still have the scheduling queues or capacity schedule allocated with Yarn. So you can say, group A within my company gets 20% of resources, group B gets, whatever, 30% of the resources. It is still centrally managed from a capacity perspective, but the resource manager is the one who is controlling those resources. Node manager, as we saw, it's a per machine agent, right? It basically manages the life cycle of that container, right? It hosts the container. Within the container, your code runs, and it's basically running on that particular node. Right? So that's your slave for that, for your particular cluster. Node manager is also responsible for container or resource monitoring, right? Previously, job tracker was tracking all these and resource monitoring for entire cluster, whereas we have separated that for individual resources. That's done by node manager or where the container resides, right? Application manager, right? So it's per application, right? It was on the next slide anyway. So you can spawn as many application masters you want, right? So if you submit a MapReduce job, because now your MapReduce job becomes a user library, It'll spawn a application master. It'll ask for the resources or containers from a resource manager and execute what it needs to execute, and then basically give the containers away, right? Edge-based, for example, edge-based on Yarn, your edge-based master server will be your application master. It'll be persistent as long as you basically give the resources away, right? So that's basically the application master. It manages the task, it manages the application scheduling and task, whereas it is responsible for requesting resources what it needs. So there's no longer concept of job tracker doing all these resource management for you. If you need resources, go ask resource manager. When you're done with resources, free up those resources, and resource manager will track all those responsibilities. You also manage and monitor your own, children or containers. There's no responsibility of the resource manager. So if one of the node where it's running the containers dies, it's the application manager's responsibility to go to the resource manager and say, hey, I need 4 more containers for my job to run. Whereas if your application master dies, it's his parent's responsibility. An applications manager parent is basically a resource manager. So application manager is dead. For example, a node dies, the resource manager will restart that application manager on some other node where you have the space or resources available, right? So it's always hierarchical. So the children to the parent to the parent.
What's to prevent an application master from asking too much?
So not at the moment, nothing, right? So it depends on the queue.
There is actually.
Yeah,
There
so
is, you can cover that.
Right.
When you connect to resource manager, you can query how much test totaling. There's a over the cap. Resource manager will not give away limited resources. It always has a cap.
right, so there's a capacity scheduler running, right? So depending on how much capacity is allocated to you, right, you will get that capacity. So let's say you're group A and you only have 20% of the cluster resources, you cannot ask more than 25% resources if you have a hard quota. But if you have no quota, you can ask for as much as resources you want. Only it's available, we'll give it back to you, right? There's a concept of soft quota as well. So if you have 20% of the cluster resource, you have soft quota, and the resources are available, you can go back and get that resources, right?
So if an application master dies, wouldn't be its node like the node manager its parent, like in a hierarchical order, like resource manager and the node manager and then the application master?
No, so if the application master dies, there's an application context, and we'll cover that in the code review, right?
Okay.
So the application context basically makes the identity of the application manager available to the resource manager. So it is aware that this is your application manager because this is the first container that was asked by the user code, right? And it basically identifies that is an application master, and it is responsible for restarting that. And node dying is basically, again, if the node is, let's say a node has application masters and other containers on that node. So let's go here. So let's say I have containers here, right? This container is this AM2 containers are on this guy too. And if this application master dies and this container also dies, this AM2 will request the resource manager that I need another container because that container is dead. But resource manager will basically see that this application master is dead. He'll spawn that application master as container 0 on some other node. Whereas it's his responsibility to get this container 1.2 because it's dead.
So the reason that the application manager is not the child of the node manager is because you can request resources from across the cluster.
Right.
If you only could ask resources from within the same node, then that would make sense, right?
Well, so node manager cannot give you any resources. The application manager asking anything on node manager doesn't make sense, right? It only can go to the resource manager who has a central repository of resources and say, give me the resources. You can ask that I want resources on this particular node, right? If the resources are available, you'll get it. You can also say, give me resources on this rack, anywhere. They'll give you the resources. It is essentially locality aware, right? Because if you say, I want resources on node, whatever this node is, node manager number 2, and if the node manager 2 is, for whatever reason, it's not available, A, it exhausted resources, B, is down, Yarn will essentially try to allocate resources first on that particular rack because of the locality of the data. Because you think that for your application is important, you'll be hosted on that node. And Yarn thinks next in the algorithm that next to this node in the same rack is more important rather than giving you on this particular rack. If nothing is available on that rack, then sorry, just go find it.
I have a related question. Let's say you have Hive as an application running, and let's say it's running on AM1. Now the clients are connecting to AM1. AM1 is down. You brought up AM2 using your management policy. So how would the clients know that AM2 is where I should connect to?
So that's a good question, right? So,
When you say you connect to Hive, it looks a little differently today. You basically interact with, say, with Hive command line, and you submit a query, and it gets converted to a job. So you just have to talk to a resource manager, and it figures out where to send it. If you come to a point where you talk directly to the application master, because with Hive you don't talk directly, you submit a query and figures out where to run it, right?
But from the client perspective, let's say I have a client which is just submitting the request.
Yeah, well, let's not call it Hive, let's say some application, you ran application master and it goes down, your clients have to go elsewhere, right? So that's a classic failover scenario. I'm talking about just regular application here. There's no automatic way to do it, but if you, let's say, deploy one of the apps masters as a load balancer and have the previous settings zookeeper, for example. We won't go into details today, but you can look at page waves on your blog post on our site, and they go into actual workflow, what happens, why, and when. It's very interesting to follow and gives you this fabric to reliable applications. So they basically put load balance on the same cluster, and it becomes discovered.
The other thing you can do is something called a blacklist or whitelist, right? So let's say you have this Hive server running on node A. The only thing for that application manager whitelist available, or I don't know, it's the other way. I always get confused white or blacklist, right? So let's assume that this application manager can only run these two nodes. So it's basically your client responsibility to check on one of these. So you can do that in simple DNS handling or CNAME or whatever you have in your environment. So in a whitelist scenario, again, check whitelist or blacklist. You can control where those application manager can spawn, right? Okay, so we already covered that, right? So the design, one of the design, question was, or their design decision was basically split these resources. They said the application management is hard because the job tracker is doing not only cluster resource management, but the application management as well, right? So it's doing speculative execution, it's collecting the information on every task. What's the progress on the task is, right? If the task dies, it's basically handling the redundancy on the task. If the task is dead, node is dead, goes spawn the task on the other node. So it's running on the same daemon. So if you're running on, basically if we separate those roles, now you have these hundreds of application masters that are doing their own resource or application management, not the resource management. They're doing their communication with their containers. They're managing their task progress. The resource manager is only responsible for, you ask for resources, here you go. So they wanted to basically separate the resource manager and make it completely agnostic of application management. That's what Yarn is all about. It's the resource manager for the entire cluster, right? And we talked about this, MapReduce becomes a user library. So let's see what happens, right? So in a typical Yarn application or Yarn architecture, your client comes in, it asks for resources to the node manager. It's the same way. You went to job tracker, you submit a job. In this case, you basically go to resource manager and ask for a resource. And you'll see when Yarn goes through, there's a specific API you can call for doing that, right? What resource manager says, okay, I have this node where you ask for 6 gigabytes and 4 vCPUs. I'll give you a container. That's your initial container called container 0. And you'll start that job on that particular start application manager on that node. Now, once the application manager started, and you'll see the application context and what kind of application you want to run, and it's fairly flexible. Once that application manager spawns, it's his responsibility to say, okay, I would like to run this code on 10 things or 10 nodes. So application manager will go back through the application manager, resource manager client and say, okay, give me 4 containers or 5 containers. In this case, I got container number 2.1. And then we'll talk over a different API called application manager to node manager and say, go, Mr. Node, start this container for me. And this container has, this resources as well as, I would like to start on you, on you, on you. So if the idea is not to hard code it. So if your application needs the resources to dynamically grow or reduce, you can demand those resources as your demand grows or as your demand shrinks, you can release those resources. So there's no hard coding like MapReduce that I need 100 containers to begin with. So if you ask for 100 containers, depending on your capacity, you will get it, but then essentially that's your hard limit, as you said, right? What's my limit? So once you schedule what that quota is for the particular user or group, you're going to get that many resources. But the idea is there's not necessarily need to ask those resources to begin with, right? Same thing, right? So you got the containers. Now if I need additional resources, I'm going to go back to Resource Manager and say, I need resource on this node, right? And it'll spawn that on particular node, right? I'm going to go back to the same slide, right? So important things of a concept, right? So going through the building the applications, right? The 2 things you need to understand. One is an application. So application for Yarn is essentially a service or an application can be a MapReduce library, MapReduce job within the Yarn. Second thing is a container. Container is essentially a smallest unit of or a basic unit of allocation. So you have memory and CPU today, and eventually you'll have disk and network resources. 2 things you have as architecture-wise, you have resource manager, who is responsible for resources throughout the cluster and manages it. The second thing you have is essentially node manager. So node manager is the daemon running on all the nodes who host all the container. The third important point is application manager, which basically runs in your default container 0, and it spawns the resources. So it's always child-parent relationship. So resource you request from your client that I need resources, it spawns application manager requests the resource manager to get resources, it does what it needs to do, and release the resources as, after the application is done.
Yarn run is something, in other words, is it, like the old way you can have job packers on one node, and the rest, the whole system. Is Yarn run on one node, or
Yeah.
is it run self-contained, or can you run other applications on it as well?
So it depends on the cluster utilization, but depending on the larger cluster, it typically becomes self-sustained eventually.
Make things more concrete. Let's say take storm, for example. How would you utilize
Just hold on to that thought. 2 slides down, you have
You know,
like, there's examples for
running
Sean.
already. Stone is running young already, so basically, the thing about the Windows container, it maps natively to node manager. So the location master and Windows the node manager, so it maps out to those very closely. And if you download the code today, which runs Stone natively Yarn. I just Yahoo showed it and it's available. It will take a minute to find out.
So today, and this is the last slide I'll run through, and then I'll hand it over for running through how to build an application, right? So what we have so far we have Quota, right? This is what happens when you have engineers to name the product, but it's nothing but Hadoop on Yarn. And we have Goya. We can't name Goya because we already have the computer-wise. That's giraffe on Yarn, but that's the different story, right? So the code is not modified at all from HBase perspective, it's just the deployment is different on Yarn. As well as we have Storm and S4 already certified on Yarn, so you can deploy the code today. Test, the generic framework for running complex DAG, which eventually will become the processing engine under Hive, will be released as beta September timeframe and full GA in January. So it also runs on Yarn. It is designed from ground up as a part of Stinger initiative for Hive, right? Making Hive faster. MPI we talked about, we had Spark and Giraffe and Master Worker. We already have them certified, and you can download the code from them as well as from if you have existing code you can run on Yarn directly. That's the bottom line, right? Run everything on the same cluster, utilize the resources, the scale, agility, right? And having a cluster which can take advantage of all the resources. So that's basically what Yarn is. It's a resource scheduler for next generation of Hadoop. So it's not from Hadoop 1.0 to Hadoop 2, it's not just a code wrap, it's really the next generation of resource scheduling. So it really fits best. Any? Okay.
Question about the HBase on Yarn. So we can take any, or I can take any HBase release from Apache and install on Yarn? Or?
Yes, you can run 4 HBase releases for that matter, because there's no restrictiveness, right? Okay. All Yarn does, it gives you resources. Yarn doesn't care what you run. It is completely agnostic. Yarn doesn't necessarily need HDFS also. It's just a resource scheduler. So you're going to say, and that's the beauty, that adds to agility, right? So today you have HBase 0.92 running, and you have some hardcore things you did in your application that needs that specific thing. You can run that as an application master, and you can run that 0.94 with whitelist enabled side by side and control the resources.
It does not create more layer between the HBase and SDFS, which we already have multiple layers.
No, but there is not, right? So it doesn't make any difference because HBase's responsibility to talk to HDFS. It's not Yarn's responsibility. Yarn is all saying, you need resources, I'll give it to you. It's in your code how you get the data from HDFS. You want to get the data from NFS share? Go do it in your code. You want to write a Perl script and run Perl script across all the nodes? You can do it. The code he's going to run is simply a shell script, and it's going to go run data across all the nodes. There's nothing in HDFS for that matter. You can run anything you want. And that's basically the next thing is you don't want to run a specific Java code. You can just run a shell script.
Just separate question.
Yes.
On the monitoring side, so Hadoop 1.0, that's the main point about how you monitor it. Like you get all the ganglia and everything else, but there was no default monitoring per se 1.0. So do you have anything built in Yarn, which you have now multi-layer, but if you start running a Yarn cluster, you will able to see what's going on there.
So the question is how do you monitor it, right? At the end of the day. So the Ganglia extensions will be available for Yarn also, right? So to essentially report on Node Manager and Resource Manager. You already have Ganglia instances or Ganglia extensions for HBase, HDFS, Hive, and what have you, right? So those will stay the same. Where they get deployed, you can deploy a Ganglia extension on all nodes. So when you start Ganglia, you're basically looking for a Hive daemon running on that particular node, right? Or a specific node. So that doesn't change. The only thing is, in addition to it, is basically the extension for Yarn, Resource Manager, and Node Manager. There's no patch tracker or anything per se, right? So those are going to change.
How does it persist the state?
Who does persist?
So how does Yarn master or resource manager persist the state? So you submit 10,000 jobs, they're running. So how does it persist which jobs are in progress or in flight?
So Resource Manager is not aware of any jobs in flight or in progress. The Resource Manager says, you're the application manager, you're running a application which needs 10,000 containers, right? Okay, do you have, from a capacity perspective, are you the user who we can give you that capacity? If the answer is yes, you're going to get that resources. If you don't, let's say capacity scheduler say, oh, you can only get 20% of the cluster, and you have 100 resource units, you're not going to get 10,000 units. You're going to get 10 at a time.
Well, once you got those units, you're running something there. So who's tracking that?
So that's your problem with application management. So you run a job, your application manager is responsible for tracking that progress of the application. It can be a MapReduce job, you submit it to Yarn. It can be an HBase, HBase is responsible for,
Maybe
reporting
you can
on
give an example how Quota does it, which base.
Right.
So they serialize the cluster state to JSON and dump it from HDFS. So if you keep the application lost, region service is not. You can still create HBase and just give it the configuration location. It goes reads configuration of the cluster. And every time you resize the cluster, for example, you just updates the version and dumps it back in HDFS. But that's just an example of how we do it today. Any configuration means we'll store it in the key base, it can fit if it's not too large. You can store it in the database, save it on SAN, doesn't matter.
It's application specific.
So understand you are no longer restricted to running as MapReduce, and you are no longer restricted to talking to HDFS only. HDFS, don't get me wrong, it's a great means to distribute applications and deploy roles out of Hadoop and raise some of those. Sometimes you just want to talk to the disk or you want to talk to some network ourselves. Do it, no problem.
If you're running an R core, you just want to talk to local disk, you can do that. If you're going to remove HDFS underneath for the cluster FS, by all means, for CPFS, pay for it, yeah.
So is it a prerequisite that you have HDFS to run Yarn?
Technically no, but it's basically coupled together as a part of Hadoop release, so it's always being coupled as it is. So if you're going to build Yarn by separate, yes. The other thing is for a MapReduce, if you're on another point, right? So the MapReduce is a little bit modified. So now when you run a MapReduce as a user library, what happens is anything that's going on as a state of MapReduce job, it writes as a transactional log into HDFS. So if your MapReduce job is progressing, we're writing that status of the MapReduce in HDFS. So when your application manager fails where you're running the code, what's going to happen is when we restart the application manager, we're going to look for that URI, and he's going to point into your that application context where that URI could be important, and that we're going to read that URI and say, okay, this is where the task was, and I'm going to restart application manager to continue from that point on. Right? Typically, if today job tracker fails, you resubmit everything, right? And that will go away because that's one of the things that built into it. A couple of things that gone into that code is the clients now can wait. So the client, if you're using an HDFS client, Hive client, or any other client, they have a pause and retry mechanism. So a master service, in this case the application master fails, while it's getting restarted, the client will pause, and it'll keep retrying until the service comes back online. So the pause and retry mechanism is already in Hadoop 1.0. The MapReduce 2 transaction logs, putting onto HDFS and let resource manager start, it's part of Yarn.
So if I understand it correctly, when HBase is running on Yarn, the HMaster is just an instance of application manager?
Correct.
HBase is not Yarn at all. It's just launched by Yarn infrastructure.
Okay.
And it runs as HBase unmodified. There's
Okay.
nothing to change.
But essentially HMaster will run inside an application manager container.
I don't know the exact details. They can launch it in a different way, or they can run it as part of the application master. It's just a design choice.
Okay. And so for MapReduce, what is the equivalent? I mean, like the HMaster is still there, right? It is running either in a container or in the application manager. For MapReduce, what we used to call job tracker, what is that now that runs in an
So
application?
think about node managers. They actually run workers. It's not exactly multi-threaded, but say multiple parallel processes will run on different nodes, and node manager will physically execute them. So your MapReduce job is just a directed cycle graph. It just series of steps. So each step gets executed somewhere. You just keep submitting them. The big difference now is in MapReduce ones, you have to split your cluster and say, I have 10 map slots and 5 reduced slots. And even if you're not doing any reduce operations, you are wasting up the cluster. Now it's different. You need to do 15 reduces with just another step you can mix. Doesn't matter.
Yeah, and if you want to start 5 tasks, you're going to get 5 containers. As simple as that. You're not going to basically get any more than that.
So does it consider data localization also?
It's a core level. It tries to execute the task as close to data as possible. Well, it tries its best. It's not always possible.
But that's in MapReduce, it has nothing to do with Yarn. Yarn has not, I mean, in a nutshell, Yarn is not data local aware, right? So when you start a MapReduce job, you're gonna still ask name node that where are all, in HDFS 2.0, it's in your namespace. So you're gonna go to one of your name nodes and say, where are my blocks for these files? And it's gonna say, okay, here are these blocks. The application manager is gonna be responsible to start the task on those. So it's gonna go to the resource manager and say, give me containers on here, here, and here. This host, and this host. That's what you request, right? And now, if that's not available, we're going to start on the same rack because we assume that the data locality, the HDFS works, is first copy on one node, second copy on the same rack, third copy is elsewhere. So that's in the MapReduce application. Yarn is basically waiting. Okay, where do you need resources? You go figure out what your data locality is. Does that make sense?
So application manager will be aware of data locality.
Application manager is basically a container. It's a container
It's not
first
the-
container. So application running within the application manager should be aware of data locality.
Just understands the way MapReduce achieves it. It talks to the main node, secondary node
Yeah.
that is available.
So here
And
instead of
asks for this file, where are the physical blocks? And just comes back with host names.
so instead of talking to name node, it will talk to resource manager.
No, it will still talk to the name node. There's still name node in HDFS
Okay.
to go, right? So you're saying now name node. So you started your application manager. Okay. So where it is. So let's go here. You started your MapReduce code. Your application start says, okay, I need to process, web log 1. Okay. So it's going to go ask within the application name node says where is web log 1 logs. It's going to tell you it's here, here, and here. What's the next step is going to happen is going to say, okay, I need containers here and here and here to process these blocks. So it's going to go to the resource manager and say, give me container here, here, and here. And then your code is going to execute. Resource manager is not aware of what exactly blocks you're looking at. It's your application responsibility. Make sense?
Yeah. And one more question about the HBase. Region server will also be managed by independent application manager.
Right. So the application manager is basically responsible for managing region servers. So the region server failover is the responsibility of the application manager.
Okay, so if one of the node fails, there are possibility that there are two region servers running on one node.
Yeah,
Right?
it's
Because
possible. Yeah,
there can be more than one application manager.
Yeah. So the containers are, basically self-contained. They're not aware of each other, essentially.
I think what you're asking, it can be run then two region server on the same node manager.
If the resources are available, yeah.
Yeah, so we can-
So today you cannot run that two.
You
region
cannot,
server.
yeah. They're because the daemon runs as it's called.
Okay.
Right?
So two region servers are two containers or two application managers?
Two containers.
Two containers.
You can run that.
Two containers.
Because any code running within the container is not aware of anything outside the container.
But what he said, like, it will be managed by not Edgemaster or Zookeeper, it will be managed by application manager?
Now, the
Edge-
bookkeeper is still there.
Right.
It doesn't change.
Edgemaster is still there.
Yes, everything is still there. It's how you initiate. Well, what we didn't cover, I'll probably talk about it more, is what else you get from Yarn. It's not just give resources.
Maybe that diagram would help if you have how the Edgebase layout on top of
So when you get a container, you get something called a container ID and a token ID, right, from resource manager. Token ID is essentially a handshake key in between resource manager and the node manager or the particular container. So they only responsible that this context is only available for this application manager. And within that context, you have these many resources. So you have 2 CPUs and whatever, 4 GB memory. So you cannot override that container by expanding the resources or basically tagging onto any other containers because you only have that particular ID. So it's basically token based from a communication perspective. And again, it's security too. That you can't really go across the task. You want to come up and talk about that? Yes.
I have one question. I think this will be pretty quick. So right now it's just resources. It's just resource allocation. So if I have HBase and Giraffe or Spark on the same Yarn cluster, there's currently no real cross-application compatibility yet. It's just if I wanted to run Spark machine learning on top of my HBase data, Spark will still need to go through the
HBase
HBase region
API.
servers to pull
Yes.
data out. Okay.
From Spark, you need to call HBase API and talk to HMaster,
Okay.
and then basically give a response back.
Right,
It's
so I-
not necessarily, if they're running on the same server, it's just the back on the API, but that's pretty much it.
Gotcha.
Yeah, it doesn't, from a Yarn perspective, I have this server, right? It has, so many virtual CPUs and so many memory. How much
Right.
do you need? You can run in 20%, this guy runs 20%, he runs 20%.
Yep,
I
as I
don't
was
run,
saying.
I don't care what you run.
Yeah, I was just curious, since they're all running on the same HDFS,
Right.
if there's some kind of cross compatibility, like, oh, I can just talk to the HBase files themselves,
Yeah.
but not yet. Okay.
Well, I mean, from a Mac reduce perspective, yeah, there is a direct access to files, but still it's an HDFS API.
Right.
There is no direct access to just you say, give me this. You still go, but all the communication happens exactly the same. You go to the name node, ask for the resources, you get it. You
Okay.
call an HBase API, you go get it, right? If it's a storm, you created a bolt to ingest the data onto HDFS, it's still going to talk to the name node, tell me where to ingest the data. If
Okay.
you're a storm, you bolt it onto HBase, you now talk to HBase API rather than a node. There's no
Right.
node concept right anymore.
Okay,
Right?
fair enough.
Okay.
Thanks.
Thanks.